Welcome to the Detroit Diesel Series 60 Air Intake. Welcome to the Detroit Diesel Series 60 Air Intake course. This course is designed to prepare you for taking the G2 certification test. There are review exercises throughout the course to reinforce learning, but there is no final exam. After completing the air intake course, you will be able to describe the purpose and function of the air cleaner, describe the purpose and function of the intake manifold, identify inspection and cleaning procedures for the. In this chapter, you will see how air is delivered to the engine. The air intake system consists of an air filter, a turbocharger, a charge air cooler, and an intake manifold. Air filters are designed to remove foreign matter from the air and pass the required volume of air into the engine for proper combustion. Keeping the engine intake air clean and dust-free is. As air enters the system, the air filter collects dirt and dust. The air filter must have a capacity large enough to retain the material separated from the air and permit a reasonable length of engine operating time before cleaning of the air filter. If dust enters the engine through the air filter, it is carried into the cylinders and causes premature wear of moving parts. If the air filter is not serviced at regular intervals, it will become plugged. A plugged air filter is actually an air intake restriction that will cause the engine to overfuel. This results in heavy carbon deposits on the valves and pistons, which is a result of incomplete combustion. Disconnect the air hose to the VNT actuator. Connect a regulated air supply to the VNT actuator fitting. Slowly adjust air pressure. The VNT turbocharger adjusts the gas flow cross-section at the inlet of the turbine wheel in order to optimize turbine power with the required load. At low engine speeds and load, little energy is available from the exhaust to generate boost. In order to maximize the use of the energy that is available, the vanes are closed. In doing so, the exhaust gas is accelerated between the vanes and across the turbine wheel. Under normal operating conditions, the vanes will transition to supply the correct amount of boost to the engine for optimal combustion. The